Hello there, my name is Robert Benge, and I'm here to talk about our bullet momentum experiment that we performed the other day. The purpose of this experiment is to display the impact of a bullet on a stationary target on different surfaces. For this experiment, we will use the impulse moments that we learned about in class to describe the work done by the bullet on the system. In this experiment, we set up a 1 gallon milk carton target and a 2 gallon milk carton target about 10 feet away from the firearm, sitting on a table, and we set them on top of either the table on its own, which would give us a polyethylene on polyethylene surface, or we put them on a plank of wood on top of the table. So it would be the wood coming into contact with the milk carton. Each trial, we recorded the distance traveled by the jugs on the plastic table, and also we recorded the distance traveled along the wooden planks. We made several assumptions while performing this experiment. The first of which is that the work done by the wind on the bullet is negligible. Next, we had the bullet is traveling at the precise speed as described by the manufacturer, which they gave to us as the muzzle exit velocity at 365.7 meters per second. We also assumed that the bullet would always act directly in the middle of the target, regardless of where we shot. We assumed that this was a perfectly plastic collision, which it was, and we used the coefficient of friction between polyethylene surfaces as 0.2, and the static and kinetic friction were the exact same. Also, for the coefficient of friction between wood and polyethylene, we had the static and the kinetic values at 0.5. They were the exact same. A few important equations here are our work equations and our impulse equations, which we have listed. Before we even took any shots, we theoretically calculated multiple values. We found that the theoretical speed of the final system during the impulse of the bullet, V2, for the 1 gallon would be 1.16 meters per second, and for the 2 gallon, V2 would be 0.579 meters per second. And below we have a picture that describes what exactly happened when we shot these gallons. In this case, it's a wood block for the sake of simplicity. Also, for the theoretical values, we found the distance traveled by each object in each scenario. For the plastic on plastic, we found that the distance traveled for the small 1 gallon would become 34 centimeters, would travel 34 centimeters, and in the plastic on plastic 2 gallon scenario, we found that it would travel 8.54 centimeters. Here in the plastic on wood with the 1 gallon, we found it would travel 11.06 centimeters, so less distance than plastic on plastic because of more friction. And then the plastic on wood for the 2 gallon carton, we found would travel 2.76 centimeters. Now, with our experimental results, we were quite surprised with this. We found that our trials for the plastic on plastic with the polyethylene surfaces sat around 1.7, 1.8-ish, around there. And on the plastic on plastic surface with the 1 gallon, it sat around 2.75 to 3, around there. And with the oak wood 2 gallon experiment, we found it went from the range of 0.4 centimeters to 0.55 centimeters. Also with this, we found the oak wood 1 gallon to be 1.2 centimeters traveling and 1.5 centimeters, which is significantly lower. Now we're comparing our results. We found our results were starkly different than what we had calculated. And we wondered to ourselves, why was that? After a bit of brainstorming and reminiscing about what we actually did, we found we weren't the best shots. To be fair, we weren't very good at all. We had a lot of human error with our measurements, careless looks, this, that, and there. And it was also raining on and off while we were performing our experiment. In conclusion, this experiment could have been performed a lot better, much more efficiently, with a bit more funding and proper equipment and materials, and also a better understanding from us, the students. However, our team persevered, we got the job done, and we expanded our knowledge on impulse moments and work done by bullets and plastic collisions. Thank you for listening, and goodbye.